All right, hi everybody. We're going to start our series of videos for Chapter 10 today, our second t-test in our series of t-tests. So last chapter, Chapter 9, we did what we were calling single sample t-tests. And you should recall that means we gathered one sample, single sample, and we measured that sample one time, single sample. So today is the first chapter where we are doing a hypothesis test where we have two sets of data. And in research, there's two different ways you can end up with two sets of data. One of the ways is that you get two different samples. I could get a sample of college freshmen and a sample of college seniors and see if they're different from each other on some variable. I could gather a sample of males versus females. I could grab a sample of folks on a particular treatment or medication and a sample of folks that are not receiving that treatment and compare them. The other way of getting two sets of data is to get one sample but measure them twice. So we could get a sample and measure them before they take a medication or after they take a medication. Sample them in this condition. Say we could sample them if our variable was about, let's say, room temperature. Does the temperature of the room you're studying in affect your memory? Well, we could put a sample in a cold room and see how they do, and then put those same folks in the hot room and see how they do and compare them to themselves. So we can either gather two different samples to compare against each other, or we could gather one sample and measure them two different times under two different situations, two different conditions. We call that treatment conditions. So we're going to do both of those things. One of those is Chapter 10 and the other is Chapter 11. So today, independent measures t-tests. This is the first thing we talked about. For an independent measures t-test, we're going to gather two separate samples that are representing two separate populations and compare them against each other. So the examples I just mentioned, if I got a sample of males, they represent a population of males, and I get a sample of females, they represent a population of females. Those are two separate samples representing two separate populations. And then each population just gets measured, each sample just gets measured once. I just measure the males one time, I measure the females one time, and we're done. So that's what an independent measures t-test would be. Two separate samples that are representing two separate or independent populations. We measure each of those groups once and just compare them. Are they different from each other or are they not different from each other? That's the heart of an independent measures t-test. So what we have is basically our same four steps that we always go through. And we're going to go ahead and start talking through those steps right here, right now. So step one, as we know always, is to state our hypotheses. And again, it's eternal. There are only two hypotheses. There is an alternate hypothesis, and there is a null hypothesis. And remember that they're going to essentially predict what they always predict. The alternate hypothesis is going to predict that there will be a difference, and the null hypothesis is going to predict that there will not be a difference, that they will be the same. Oh, I need to clarify, one-tailed, two-tailed, just got into the pattern of it. We are doing the two-tailed version. So again, we're only asking if these samples are different from each other statistically, not if one sample scored higher or lower than another, just if they scored differently from each other. So let's think about the null hypothesis first for a second. It's a little bit easier for a lot of students if we start down here. So remember, the null is going to predict that these two groups are not going to be different. So remember, we've got two samples representing two different populations, and we're asking about the difference between them. So we have the first treated population mean and the second treated population mean. So from our first group and our second group, and we're asking about their differences. Are they different from each other? Well, think about it. If the null predicts that these groups are not different, it's another way of saying that they're predicting they are the same. Well, if I put the same number, if I replace the symbols with numbers, if I put a 10 here and I put a 10 there, or I put a 50 here and a 50 there, whatever two numbers, a number minus itself will what? Always equal 0. So this is how we're going to write out our null hypothesis, that the difference between them will equal 0 points. Essentially, they're the same. There is a different way of writing this that, quite frankly, is a little bit simpler, but we're going to write it this way because it's going to help us to simplify a calculation when we get to step 3. One of the things that we haven't really talked about and that you probably haven't noticed is whatever we write for the null hypothesis, if you go back to chapters 8 or 9, whenever we write treated population mean doesn't equal some number, if you look at your calculations in the formula for the statistic where the population mean value is, where the mu is in the formula, that's where that number goes. It comes out of the null hypothesis. So we're going to be able to use this to help us mathematically later. So unlike chapters 8 and 9, where we had to look at a story problem to know what number to put down here, we don't have to do that in chapter 10. It will always be a 0 at the end because we're saying the difference between them equals 0 points. So there isn't any number to pull out of the story problem, which means that there's only one thing to write for every single two-tailed independent measures t-test. There's only one way to write that down. So now let's move back up to the alternate hypothesis. The alternate hypothesis is treated population mean 1 minus treated population mean 2. Well, if these now are supposed to be different values because the alternate hypothesis is predicting they will measure differently, perform differently. Well, if these are two different numbers, I don't know what number we will get, but I know what number we won't get, 0. So the alternate hypothesis is treated population mean 1 minus treated population mean 2 will not equal 0. The null hypothesis is treated population mean 1 minus treated population mean 2 will equal 0. So for our two-tailed version of this test, this is the only way of writing our hypotheses. There is no other version than this. So that's our first step. We're going to continue through our 4 steps in the next video segment.